Boolean logic has dominated our thinking for centuries. True or false, 1 or 0, on or off. It's the foundation of modern computing and much of Western philosophy. But what if this binary approach is actually limiting our ability to model the real world? Ternary logic offers a compelling alternative by introducing a third value beyond just true and false. This third value can represent concepts like unknown, undefined, maybe, or neither. While this might seem like a small addition, it fundamentally changes how we can represent and reason about information. Consider how often we encounter situations that don't fit neatly into yes or no categories. Is it raining outside? If you're indoors without windows, you simply don't know. In Boolean logic, you're forced to choose true or false, but neither accurately represents your state of knowledge. Ternary logic allows for this uncertainty with its third value. The limitations of Boolean logic become even more apparent when dealing with future events or incomplete information. Will it rain tomorrow? Is there life on other planets? Boolean logic demands definitive answers when none may exist yet. Ternary logic acknowledges this fundamental uncertainty. In computing, ternary logic offers theoretical advantages too. A ternary computer could represent more states per digit than a binary one. Each ternary digit or trait can represent 3 states instead of 2, making it more information-dense than binary digits. This means potentially more efficient data storage and processing. Database systems already recognize the need for 3-valued logic. SQL, the standard language for database queries, implements null as a third value distinct from true and false. This allows databases to handle missing or inapplicable data in a more nuanced way than strict Boolean logic would permit. Philosophically, ternary logic aligns better with Eastern traditions that often embrace the middle path or reject strict dualism. Ancient Indian logic recognized several truth values, and Buddhist logic explicitly rejects the law of the excluded middle that underpins Boolean thinking. Even in mathematics, there are systems where propositions can be undecidable, neither provable nor disprovable within the system. Gödel's incompleteness theorems famously demonstrated this limitation of formal systems. Ternary logic provides a natural framework for representing such undecidable propositions. The human mind itself seems to operate beyond simple Boolean categories. We constantly deal with probabilities, uncertainties, and partial information. Our natural thinking includes concepts like maybe, probably, and I don't know yet, that don't map cleanly to Boolean true or false. Fuzzy logic, which extends beyond ternary to infinite-valued logic, takes this even further by allowing truth values anywhere between 0 and 1. This approach has proven valuable in artificial intelligence, control systems, and modeling complex real-world phenomena. Boolean logic remains powerful and useful for many applications, particularly in digital circuit design, where physical components tend to have 2 stable states. But as we build more sophisticated systems to model our complex world, the limitations of binary thinking become increasingly apparent. By expanding our logical frameworks beyond the confines of Boolean thinking, we gain the ability to represent uncertainty in completeness and nuance. Ternary logic isn't just an interesting theoretical alternative, it's a more accurate reflection of reality in many situations. Perhaps it's time we moved beyond seeing the world in black and white and acknowledge the vast and important gray areas in between.